Okay, so here we're asked to fill in the missing values to make the equations true. And let me pull up just the general rules for a second. And what I want you to notice is that in these rules, everything is basically the opposite of what it would be if it were an exponent. So with an exponent, right, addition inside the exponent is multiplication outside the exponent, right? So for exponents, like if you have 3 to the 2 plus 5, this is 3, oops, that's supposed to be a 3. This is 3 squared times 3 to the 5th, right? So if inside the exponent it's addition, but if you make it outside the exponent, it turns into a multiplication. So for logarithms, it's the opposite, right? Logarithms kind of multiplication inside is addition outside, right? If we split it into two, here you're kind of, rather than saying inside and outside, maybe I'll say like a single exponent versus splitting it into two. If it's a single exponent, right, then the addition's happening inside the exponent. There's addition, but if you split it into two, it becomes multiplication. Here, if it's multiplication kind of inside a logarithm, it's multiplication, but if you split it into two, it becomes addition. It's the opposite. And because you can think of it as a logarithm really is an exponent, okay? So actually, if you say that to yourself, a logarithm is an exponent. Why is a logarithm an exponent? Right, if I have something like 3 squared equals 9, then log base 3 of 9 equals 2. So the logarithm, what is log base 3 of 2? It is the exponent. So this logarithm is an exponent. This logarithm is an exponent. So this addition, you're kind of adding exponents. Okay, so this is adding exponents, so that becomes multiplication. So you can kind of think of it like that. So then the same thing here, right? Just like division becomes subtraction, and here kind of the, this is a little bit unclear, but this is, let's put these parentheses here. Log base a, oops, there's still the a, of m to the p. So it's an exponent inside the logarithm. You can pull out that exponent. So let's see how we apply these to the rules right here. So what it's saying is log base a of m plus log base a of n. Okay, so that's exactly what we have here. We have the same base. So we're adding two logarithms with the same base. That's what log base a, log base a. We're adding them, m, n. What it says is that you can combine it to be a single logarithm, and what's inside here is just m times n. See that? So here it would be 7 times 3, so this would be 21. Okay? All right, so using this one, right, when you subtract logarithms, it becomes division. So again, same base, log base 5, log base 5. So this minus this, if you put it all as a single logarithm, if this is 11 divided by 4, then this has to be 4. So put that 4 in here. And here, okay, so using this last one, right, so again, log base 3, log base 3. Same base for our logarithm. This 4 as multiplication, that's this p, right? It's multiplication outside of the logarithm. Okay, so if I bring it into the logarithm, it becomes m to the p power. So this would have to be 2 to the 4th power, which is 8. Okay, so rewrite log base 3 of 8. Okay, let's try another one for extra practice. Okay, so log base 7 of 5 minus log base 7 of 2. First of all, let's just double check that the bases are the same. Okay, the bases are the same, so that's good. Now I say, okay, what's going on here? I have subtraction. So when I have subtraction, when I subtract two logarithms with the same base, and I combine them to be a single logarithm, subtraction becomes division. So what I end up having here is 5 divided by 2. Okay, moving on to the next one. Okay, first of all, let me double check. I've got two logarithms that I'm combining to a single logarithm. And let me double check they have the same base. Log base 2, log base 2, log base 2. That's good. So when I combine two logarithms using addition to being a single logarithm, addition becomes multiplication. So 9 times this equals 99. 9 times what is 99? 9 times 11. Okay? And now for this last one, right, what I'm seeing here is I have, first of all, log base 9, log base 9. So what's happening? I want to multiply this by something on the outside. So what would I have to multiply by on the outside? Well, I want to remember that an exponent inside becomes multiplication outside. And I'm noticing this 9 and I'm noticing this 3. And so how do I write 9 in terms of 3? Let me write this as log base 9. And it's this 9 right here. Let me write this as 3 squared. Okay, so this 9 I'm writing as 3 squared. And then I can use this property that this exponent, oops, that's a 2. Okay, that exponent can come out of the logarithm to become multiplication. So this goes right here. So this equals 2 times log base 9 of 3. So a 2 goes right here.